Hi and Assalamualaikum everyone. In this video, we're going to discuss about non-cyclic and cyclic photophosphorylation. First and foremost, what is the main purpose of photophosphorylation? The main purpose of light reaction is to make ATP and NADPH. ATP and NADPH will be used as chemical energy and reducing power respectively in the Kelvin cycle. So now I will explain about non-cyclic photophosphorylation first. Non-cyclic photophosphorylation involves both photosystems, which are photosystem 1 and photosystem 2. These two photosystems contain P700s and P680 respectively. This process happens when the photon here, the light energy here, strike these two photosystems concurrently. So first, I will begin the electron flow from photosystem 2. As I said just now, as the photon strike photosystem 2, the electron will raise to a higher energy level and pass to the primary electron acceptor, which is acceptor Q. This electron continues its journey to the PQ and then cytochrome complex and PC until its energy level becomes low and back to the ground state at photosystem 1. But it will wait at the PC to fill an opening in the chlorophyll P700 at the photosystem 1. So as soon as the photon strikes photosystem 1, the electron in the P700s will excite and pass to primary electron acceptor, which is ferrous sulfide. So the electron at the PC just now will fill the empty spot there. The electron at the FES will then go to the ferredoxin FD and will be accepted by the NADP plus molecule. This NADP plus molecule simultaneously will accept hydrogen ion with the help of NADP reductase and become reduced NADP, which is NADPH. So what will happen with the empty space at photosystem 2? Here, photolysis will occur to replace the electron where the water molecule split to produce electron, oxygen and hydrogen ion. This oxygen will release to the atmosphere. The electron fluids now release energy that used to pump hydrogen ion here from the stroma to the thylakoid lumen through the cytochrome complex. This causes accumulation of proton in the thylakoid lumen and drop its pH to pH 3. So to stabilize this condition, hydrogen ion have to go back to the stroma but cannot directly across the thylakoid membrane as it is impermeable to hydrogen ion. So hydrogen ion will return back to the stroma through the ATP synthase. Diffusion of hydrogen ion will induce the conformation of the enzymes that are necessary for the synthesis of ATP. So in this process, we will get ATP here, NADP, and also oxygen. So now we will go to the cyclic photophosphorylation. I drew a box here which we will be focusing on. Cyclic photophosphorylation only involves photosystem 1. This process occurs because of the lack of an ADP plus molecule. So, when the photon strikes photosystem 1, as usual, the electron will raise to a higher energy level of primary electron acceptor, FeS. Then it will be passed to the paradoxine or Fd. So as there are no NADP plus, molecule to accept the electron, so it will go to the cytochrome complex, Pc, and returning back to its ground state from where it began at the chlorophyll, P700. So the energy released throughout the electron flow will pump hydrogen ion, okay, from the stroma to the thallic limit through cytochrome complex. So the chemiosmosis will happen where hydrogen ion will diffuse back to the stroma through ATP synthase. As a result, extra ATP is synthesized in this process. So why it is named as cyclic photophosphorylation? Because the electron flow from this process is like a cycle. Yeah, as it begin here at photosystem 1, and it go here and go back to the photosystem 1 back. Go back at the same place. So that's why we call it as a cyclic photophosphorylation. I think that is all from me, and I hope you can understand more about this topic after watching this video. Okay, thank you.